Hi everyone, my name is Conan. I'm a Director of Engineering at the Salesforce Big Data team. Today I'll give a brief overview of how we are building a secured data intelligence platform at Salesforce. First, I want to share some jokes I just found today. Data science is 80% preparing data, 20% complaining about preparing data. How to make my platform completely secure? Answer, shut it down. And I just realized that all our work is trying to solve the challenges in these two jokes. Data is hard, and securing a platform is hard. How about securing a data platform? Extra hard, right? At Salesforce, I'm leading the infrastructure called Unified Intelligence Platform, or UIP. It is a data platform to help us drive insights. For example, everyone at Salesforce can use the platform to improve user experience, product quality, user growth, and IT operations, and so on. Now, a little background. The predecessor of UIP is a huge Hadoop cluster on-premise in our first-party data centers, and my team also runs it. It ingests more than trillions of events a day and stores multi-dozen petabytes of data. And we face challenges. For example, we don't have enough space. We don't have certain features. That's why my team decided to build this new platform from scratch in cloud, and we are migrating the data and the users. And I was joking that what we are doing is Mars colonization. If you look into this diagram, it follows a life cycle of data from bottom to top. First, our developers write logs, which are transported into object stores. Now, with this massive amount of data, our infra engineers need to do ETL to transform and prepare the data. Our data stewards need to do data cataloging to power a discovery and to do governance, for example, access control, retention control. And our users now can use compute to process the data. Analysts, they like to do interactive SQL queries. Data engineers like to do batch query and to orchestrate on their batch jobs. Data scientists like to do machine learning jobs. And we provide tools such as Presto, Spark, Jupyter, and Airflow, and so on. And now users can consume the data. They can use visualization tools such as Tableau. They can share in team notebooks. They can use other IDEs or integrate into their customized tools. And now everyone can drive actionable insights out of the data. There are a lot I can talk about this platform, but today I'll focus on security. Our methodology is security-driven design, as opposed to building functionality first and add security in the end, because that won't work. Imagine you are building a house, and then in the end, the city inspector says, for security reasons, you have to change it from multi-level to Rambler, or you have to change the plumbing from iron to copper. That would be huge redesign of everything and a lot of throwaway work. And building a data platform is similar. We did security design from day one so that there will be no last-minute surprise. And the last-minute surprise of a security concern can be real. As you have already read all the news about data leaks, social network privacy leaks, and everything. This would be bad for the company and its customers. And with a limited time today, I'll just pick 5 examples of our security design. First, data classification. One lesson we learned is that not all data is equal. Think of the data of our confidential company financial data versus some public data set. They are different, and this difference will have a huge ripple impact of our architectural design and the technical options that we choose for each, because they have different compliance requirements and legal liabilities. How we authenticate users to access the data, how to authorize the data access, how to share them, how to back up the data, how our developers can log into the system to troubleshoot things will be all different. If I can reuse the analogy of a building, the construction of a storage would be completely different based on whether it's a storage for a park, a bank, or a military armory. So what we did was to review with the legal and the security teams to classify the data we are going to store. And during the data ingestion, we will combine multiple techniques according to the data classification. For example, data tokenization, GDPR scans, incident handling, automation, and so on, in order to meet the requirements of the target data class. Second is data encryption. Encryption is an extra layer of security on top of the identity and access management, so that even after an intruder has got access to the data bucket, they will still not be able to decode it. So we are storing data in public clouds. That means data encryption is important. And a real-world analogy is to is for the banks to put some security deposit boxes in a vault room. The vault room itself was locked, but then every security deposit box has its own keys. And similarly, data encryption and decryption also need a key. And we have multiple options around this key. The easiest way is to just rely on the cloud vendor to manage the key on behalf of us and encrypt on behalf of us. That is to say, we trust the vendor to do everything transparently and not to give the key to anyone, including their own employees. And the middle option is we manage the keys, but only give the key temporarily to the vendor to do the encryption, decryption on behalf of us. But we control the key rotation and life cycle and so on. There will be some trade-off because you will have to manage the key rotation, and this incurs operational overhead. The most strict level is client-side encryption, which means we encrypt the data by ourselves on-premise even before we upload it to the cloud. So there's no way the cloud vendor can decrypt it. There are more options, but in general, there are trade-offs between the security level and the operational cost. And the best practice is to adopt the middle option, which is we manage the key, but let the cloud vendor to use the key to decrypt the data and encrypt the data for us. And the next is data access. And data access control is obviously one of the most important things for us because data is the key of our asset. It's almost like a hotel. We need a key card system that can decide who can access which room, which facility. And it will be all different depending on whether it's a guest, it's a cleaning maid, or it's a facility staff, and so on. And our challenge is we have a massive amount of data and many tools connecting to the data. And it serves many internal users across different product lines. And they have different clearance levels, such as FTEs, interns, contractors, and so on. So we need a unified and a coherent data strategy and a policy and a permission control so that no user and no tool can bypass the system to access some data they are not supposed to. So that's why we adopt multiple techniques, including role-based access control and synchronizing the policies between the file level and the schema level. In the meantime, we don't want the users to feel their hands are tied and frustrated whenever they need to access a given data set. So we need to balance between the least privilege versus data agility. And for data agility, for example, we provide sandbox playgrounds and self-serving onboarding automation and so on. And another thing we do is to support multi-tenancy. As a data platform, we let users to use our big data clusters such as Presto, Spark, Airflow, and so on. And one decision we have to make for each cluster is whether it should be a single tenant cluster or multi-tenant cluster. A single tenant cluster means we launch a brand new cluster for every team. And a multi-tenant cluster means we launch a shared big cluster that serves multiple teams. A shared multi-tenant cluster is typically cheaper and also involves less operational cost. But it doesn't isolate the users and the teams from OS level, so you can argue that in theory it is less secure. And also teams may compete resources. It's like an apartment building that can choose to install a washer-dryer unit in every single unit, or to install a big shared washer-dryer unit in a lobby shared by all the units. And obviously there's pros and cons. And for us, we adopt a hybrid model. By default, we use multi-tenant clusters because we want to cut cost and operational overhead. And to mitigate the security isolation, we use role-based access control, I just mentioned. And we also use tenant quota so that we can throttle the resource usage for each team. But for more sensitive users and mission-critical jobs, we will launch a separate, dedicated single-tenant cluster. And then we handle third-party security. Many big data services are from open source. They use different licenses. There's Apache, MIT, BSD, and so on. And different licenses have different legal implications and restrictions on how you can commit to the code, how you can distribute the software, and so on. And that's why we cannot just grab whatever is free online and use it in the platform. So first, before we include any software into the platform, we will do a security scan and review with our teams. And even more subtle is all the packages that can be dynamically installed. For example, our data scientists, they need to try out 10 different new packages and then decide which one to keep. So they cannot wait for a review process. But it's not a good idea for them to just freely grab whatever package from the public internet. One, because of the licensing concerns. And another thing is the package themselves could contain malicious modules. And there have been a lot of news about official Python repo PyPI containing malicious modules as well. So instead, we maintain our own internal repo for packages that are pre-scanned and revealed at the doorstep. Okay, so hope so far you enjoyed my sharing. There are more topics such as network security, Kerberos, data environment, and more details that you can check on my blog. In summary, data is hard. Securing a platform is hard. And securing a data platform is extra hard. And we welcome your ideas. Thank you.